So pitch. How do we change pitch? The phasor ramp, the frequency of the phasor ramp determines how quickly we read through the grain. So changing that would clearly change pitch. Let's just do that. 1. So if we multiply the phasor ramp, I'll give it a value of 1 here. So that initially nothing changes. So we're going to cos scalar samp hold and plus. Okay, so cos scalar samp hold and plus cos scalar sample hold and plus. Now add a value, or number box, sorry, and let's have a listen to that. If we change this value, what's wrong? What do we notice? Well, we're changing phasor ramp and the pitch is changing, but the size of the window isn't being changed. So our clicks are back. So clearly changing just the phasor frequency, or just the phasor ramp itself, isn't enough. So I'll just do Z, 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 Z. So that's clearly not going to work. So I'll put my multiplier, my scalar, in here. Oh, I better say 1. Delete, delete. So try and predict. Usually find that's a good learning exercise, is try and predict what's going to happen. I have to admit that I stumbled across this my numerous experiments in MaximSP. Many years ago, is to change the size of the grain, which changes the size of the grain and the frequency of the phasor, and then also change the size of the ramp, or the frequency, sorry. So I'll just do Control-1, signal tilde, and the practical effect is that we can change the pitch and the size of the grain stays the same, which for my purposes was desirable. In many examples of granular synth engines, when you change the pitch, the grain size changes as well, and vice versa. When you change the size of the grain, you modulate pitch. I don't like things happening over which I have no control, so this gives me control over the pitch of the grain without affecting the size of the grain. Let's listen. So you should be able to hear that the grain size isn't changing, but its pitch is. And we can even go backwards. Okay, so we have added, as I said I would, a pitch control. But can you hear? as I also said before, as you solve one problem, another one arises. It's a bit like whack-a-mole. Listen. Discontinuities, because I'm changing the frequency of the phaser mid-ramp, which is causing that crunchy zipper noise. We don't want that. So we just use our old sample hold trick. However, I'll just make my send here. I'll call it delta. You will notice that these sample and hold oscillators down here are being triggered by a phaser that is that precedes it chronologically. This phaser ramp comes out, then it goes to sample and hold. This value here is the one that I want to sample and hold, but it precedes the phaser. So I can't connect that phaser ramp directly to sample and hold. I will use send and receive objects, which conveniently introduce one signal vector of delay, which means that we can send that back through the engine. So I'm sending delta, I receive it up here, I'm running out of space again. At least I don't need to explain what all this stuff is about. If you don't know what's happening, then go back and watch video number 1 in this series. So here is my pitch value. Oh, oops, no. Coming from sample and hold into there and into there. And before I play this back, I should point out that although we've got rid of the clicks, something else happens that we need to get rid of. And you might say, you haven't got rid of the clicks are still there. The clicks are still there, but they are only present in this mirrored algorithm, this mirrored engine. They are not present here. Why is that? Because I'm using the first grain as the trigger for my sample and hold to pass this value only at the end of that phaser ramp. But over on the right here, I have another phaser, and it is changing in the middle of its ramp. Excuse me. And I can't use 2 phaser triggers to trigger one sample and hold object. And with a view to making this engine polyphonic, we actually don't need this overlapped window anymore. I used it for demonstration purposes, and if you wish to just use this engine in a monophonic version, then certainly do. So we press delete and we're back to 1 grain, but that's okay because we're going to make this engine polyphonic, and each voice of the polyphonic engine will have its own offset, its own overlap. So we can create 16 grains, and they will all be offset by a value of 1/16. Yeah, so let's just listen. I want to prove that I can change pitch without sample discontinuities. Yeah, sometimes I think there's a select object in PD. let's just have a look. Is it per data or is it? I think it's a vanilla object. How do you find out? Well, you go to quick reference and you look for select. There it is. Yes, it's a vanilla object. So sometimes if you send a 0, it gets stuck there. Oh, sorry, I need to say select 0. And at the right outlet, we get everything except 0. May need to reinitialize this. I think if I disconnect delta, there we go. Okay, so now this sample hold oscillator won't get a 0, thereby causing the engine to hang. Step 2 of this second video is we're going to wrap all this guy here, the bit that's doing the reading and the window. I'm going to make it polyphonic. I'm going to pause here, but not before I do this. Control 1. Control 1. Come on, where are you? We're going to add an offset, but we're going to add nothing. Control 1. WRAP tilde. This will still work. 1, 2, 3, 4. Cos, send delta, scalar, and sample and hold. So that's had no change, no effect. Still works. Doesn't sound as smooth now because we're just using one grain. But as soon as we make this polyphonic, we'll get our lovely buttery goodness. Before we delve into the fairly lengthy and complicated process of making this monophonic grain polyphonic, one element that is fairly important in granular synthesis, granular playback, time and pitch stretching, is to silence the grains randomly, so we can chop the sound up. And the way I do it is by muting the phaser intermittently. And I use noise to do that. So let's remind ourselves, we'll use our scope object because I want to kind of clarify the hacky maths that lies behind this. So noise is giving me what appear to be random sample values. Noise is all frequencies. So I'm going to add an expression object here, tilde, and I'm going to ask, is the signal vector greater than this number that I'm putting in? Okay. And what we're doing is we're turning that into an on-off switch. I need a number. So let's scroll down here. And down to minus, 0.9. So if I zoom into this, is this incoming noise greater than negative 0.98? And it's giving me a 1, i.e. true, most of the time. Let's slowly change that value. 1.02 is noise greater than 1.02. No, it isn't, because it's fixed in the domain -1 to +1. So I'm getting a constant 0 there. This expression object is effectively saying yes, no, yes, no, yes, no. I want to, well, first of all, I want to add a slider object. So I can input that value. So horizontal slider, and he ranges between 0 and 127. So I'll just do a little bit of maths here again. expr, and I want to say, to convert this into the region -1 to +1, I'm going to say $float1 multiplied by 0.0, I think it's 0.015, and then I'm going to subtract minus 1.02. And the reason I've made that larger than -1 is for this reason, so that I can get a constant yes or a constant 1. So now I can, using this signal value, this changing signal value, I can slice the grains a lot, or I can leave them open. So this will randomly mute the phasor ramp before it gets to the cosine function, and that will effectively turns off the ramp, or it multiplies it by this value. And I only want to do that at the end of a grain, at the end of a ramp. I don't want to do it while the phasor is in mid-ramp. So I take from ramp here, sample and hold value, and now I'm going to multiply this part by that value. Telled that was not terribly hacky. I think I'm being a bit self-deprecating there. I mean, it works. So define hacky. Now let's listen. Oh, of course, sorry. So it's constant grains, and as I raise this value, some of the phasor ramp is randomly being muted until I get up here. It's off a lot of the time, and now we're just getting very occasional grains. I simply, rather than allowing the user to scroll through grain size, I simply added, let's say, a number of message boxes, which gave a fixed value, 160, and multiples of 80, or multiples of 40. That kind of idea, and the user simply clicked to change the grain size, and yeah, I might as well leave that there. So you can have small grains, medium grains, or large grains. It's a little trade-off, but nice. clone object, which handles polyphonic voices in PD, is fairly transparent, even to the novice PD user. It's just, you have to be very careful careful with it. The slightest error and it won't do what you're expecting it to do. So yeah, I don't know what the adjective I'm looking for is. It's not complicated. It's not lengthy either. It's just fairly detailed, and it's labor intensive. So I'll get to that next. So we're back in PD, and what we've achieved so far is a simple phaser line ramp to a table read or tab read to read from a buffer containing data representing an audio file. We've enveloped that slice to declick it. We've also implemented a muting algorithm using some noise and a kind of logic gate. What's this here? Oh, this is my maths. Milliseconds to samples to hertz and back again. And using an offset into the table, we can read through the table. So let's hear that. Some blurring, which can also be amplified to give us a range value. And we're also able to randomly silence the grains with increasing frequency. Very occasional sparse grains, and then continuous grains. And we've also added a pitch factor by which we're multiplying the millisecond size value of the grain and the frequency of the ramp, which effectively gives us a pitch control. And we're using send and receive so that we can pass this phaser ramp backwards in time, as it were. Pure Data can't see into the future. It doesn't know what's coming out of here until the phaser has been set. And this is why I just, off camera, just had to add this reset message to sample and hold, because if the phaser isn't initialized, there's no ramp getting passed to this preceding sample and hold. So when we come to use the clone object, which is how Pure Data exposes or offers polyphonic voices or functionality, we're going to be putting stuff inside subpatches anyway. So let's just start compartmentalizing things, save it, close it, and make sure that it still works. So I'm going to put all this inside. Oh, I need to take him out. I'm going to put everything from the phaser down inside a subpatch. That'll be the reasons for that will become clear. The main one is that what the clone. Let's get into some detail. What the clone object does is it creates copies of a named subpatch. If we are to put the phaser inside that subpatch, what I've found in the past certainly is that you cannot guarantee phase sync accuracy of those multiple copies of the phaser So what I've found to be a more reliable approach is to keep the phaser outside the clone object, up one level as it were, and then put all the hardcore stuff inside the clone object. So this stuff is, just for the time being, I'm going to put inside a PD subpatch, and we do that by making a new object, PD, and I'll call it voice. Or grain voice dash voice. And it opens up a new window. So what do I need? I need a signal inlet from the phaser. So we'll give ourselves that first. Control 1 inlet tilde. That's my phaser. Usually a good idea, or it is a good idea, to name these things. PHASOR. Let's zoom in as well. So that's my phaser ramp. And what else do I need? I have the sample size coming in, the size of the ramp in samples. That's another signal. So I'll just copy that. And samp size. I also have my offset signal coming in. So there's my phaser signal, the sample size signal, and the offset signal. So I'll just move these guys over. Duplicate. This is offset into the table. What else do I need coming in? I have a control value coming in from muting to silence the grains. Okay. So a regular inlet. His name is muting, M-U-T-I-N-G. And this is a valuable exercise, because when we come to use the clone object, you need to have very clear, explicit control over what's going in to the clone object and where. Now, I think I'm good to Control X that, and he's going to go inside there. So where's my phaser ramp going? It's going to there. Sample size is going to there. Offset is going to the sample and hold. And muting is going to there. And just to clear things up, I can swing that around. And then we can swap these over, just to keep things tidy. Not perfect, but will do for now. And then finally I need outlet tilde for the grain to come out. And it would be here in the clone object. I would imagine that you would put some sort of panning, random panning, if you wanted to make use of that. But not for today. So our phaser goes in there, phaser ramp, sample size comes next, or size in samples, then offset, then muting, control value, and we can zoom in now. And there's lots of other stuff here we can package up into a little subpatch. Yeah, it's kind of looking better. So outlet here. So this is the boring bit. I'm just doing some tidying up. And anytime putting something into a subpatch, anytime we have one object connecting to more than one inlet on an object further down, what I do is this. So that can go into a subpatch as well. And this is, what is this? This is blurring. Okay, so we will Control X, make a new patch, a subpatch called PD blur. I need an control inlet, INLET, and I need a signal outlet. Verify. There's my signal going out. This is my low pass filtered noise that we're applying to, outlet tilde. I like the way PD does that. It doesn't let you do anything. Well, usually, very often doesn't let you do anything illegal. So there's my blur, offset. Yeah, you can fast forward to till you see me putting the clone object on screen, if you like. Unpack this as well. Oops. Control 1, PD, my line. I never use an existing name for a subpatch. You'll confuse PD. So I just get into the habit of preceding duplicate names with my. So I need a control inlet. And a signal outlet. OUTLET tilde. Yeah, and I'm not going to test things as I go. I'm just going to go for it on a wing and a prayer. Need a comment, blur. Even though the subpatch directly below it is called blur, I want to name my controls. This is good practice. So we've got muting, we've got scrubbing through the file. Now, what else can I patch up? I want to keep this send visible. Millisecond size, yes, that could go inside. Pitch could go inside, and do I want to keep that inside or outside? Don't know. I definitely want to keep reset outside. I'll just do that. And all this gubbins is going to go inside another patch. Oh dear. No, I'm not going to delete that. I'm going to do copy first, because I'll forget where stuff goes, and I'll call this pitch size. What do I need? Well, I need a control inlet for size, ms size, millisecond size, control copy, verify. I need a control inlet for reset. I need a control inlet for pitch factor. need 2 outlets. One for the ramp and one for the size. Okay, outlet tilde for the phaser signal and outlet tilde for sample size. Outlet tilde. Oh no, don't name it. You could get into that, but not right now. So I need some comments. Down here is ramp. And then over here is sample size. Out. Control verify. Oh, oops. Yeah, it just negated my previous copy. Control copy. Yes, so the phaser can. Oh no, hold on. Yeah. Do I want to see the phaser? I don't know. I suppose it doesn't matter. Pitch size. Okay, let's have a look. Okay, verify. So that's the size in milliseconds. This is to reset a sample hold oscillator. This is my pitch factor. And then out comes my phaser ramp and sample size, or size in samples. Let's see, I think there's a handy way to. Is it? Yeah, if I connect one of these. No, if I connect one of these to there. I'll connect all of them, yes, that's quite handy. Then reset, then pitch. He is the phaser ramp coming out on the left. And he is also going to the grain voice. Now, let's see if we're counting our chickens before they've hatched. No. Pretty lengthy process, but it's cleaned up a lot of real estate. Okay. Let's see if it still works. I think the sample hold oscillator will have reset itself inside the subpatch. Let's just find out if that's true. We'll go and get a different audio file. We'll go for Cherokee, normalize it. Yes, it has reset it, or it has. I click reset here. Oh, I'm muted probably. I'm just going to verify that all the pre-existing controls still work. Yes, so that might be a good time to hit pause.